Hello everyone. In this video we will see the next problem, which is maximum number of vowels in substring of a given length. So here, given the string and integer k, return the maximum number of vowel letters in any subarray of s with length k. So these are the vowels. So here we have to return the maximum number of vowel letters in any substring of a s with length of k. So here in this case, if we take in this case the maximum the substring which contains maximum vowel is this thing. So I which contains almost same number of vowels, which is 3. So if we take this string contains all vowels, so it would be 2, because we can consider any substring which will become which will have all vowels. So in lead code, if you see substring, and one more thing, you should not assume when we said k is equal to 3, you should not assume like these vowels should be like together. So we can consider even vowels shouldn't be together. So for example, here k is equal to 3, so we consider these 3 where we have two vowels. So while and also we get these other strings as well which contains two vowels. So while going through the solution, you will get a good idea what I was saying about. So these are the constants. So yes contains only lower English letters. So initially what we do is let's go through our solution. So initially what we do is we will be creating a one dictionary with all vowels, and we are here taken two variables for max count and current count. So counting the vowels, and initially we have written, so I'll just go through this and explain what's happening here. So initially, first we iterate k variables. So here abc, because we have k is 3, so we will be iterating first k variables, k characters. So abc, in this we have only one vowel, one vowel. So uh, in this we have only one vowel. Here I have written two, but this should be only one vowel. And then again in from this onwards, we'll be iterating through the remaining characters using this second for loop. So in each iteration we'll be considering next character, and we'll be leaving the leftmost character, and we will be considering the next character. So here we have considered, we'll be considered in next iteration, we'll be considering bci, will be leaving out a. So here also we have only one vowel, so we'll be getting one here. And again we'll be leaving out b, and we'll be considering cii, which is 2. We will be having two vowels in cii. And then again we will be leaving out c, and we'll be considering next three vowels, next three characters, which are all vowels. So we will be having 3. So in this case we will not be going forward, and we'll just return 3, because the maximum characters we should consider is 3. So all are vowel, so we no need to consider look into the other characters. So that is what we are doing here. So I'll go through the solution here, you will get an idea. So initially here we k times we have iterated. So we have started at a, and a b c till abc we have went forward using this for loop. And then we got current max count will be 1, because in these 3 we have only one vowel, and we'll be assigning same to current. And then we start from k is 3, so we'll be starting from here. And in each iteration, like I said previously, here we'll be considering checking if this is vowel. Yes, so we are adding one to current. So current is initially we have current to 0 0, and at this place we got 2 2, sorry, 1 1, and then 1 1, and then here here we have considered I, so we left out A, so again we will be having in current 1 and max count also 1. And then in next and here we are leaving out the so actually in current count what happens is we get like we get 2, and then again we will be subtracting, which is we are leaving out one vowel leftmost, so again it will become 1. So and then we are checking if whether current is greater than max count. So 1 is greater than 1, no, so will we not be going inside if condition. And if and also we are checking even if we don't write this condition, this program will work, but by writing this program we are making it even more efficient. Like here we are just stopping here. In next iteration again we consider next I, and and then we are checking if it is oval, yes, so again current becomes 2, and again the left out was B, because here I minus K is B. So B is oval or not, no, so that is the reason again will not be going inside this if condition, will be going inside this condition because current is greater than 1, so max count become 2, and then our current count will be 2. And then we check this condition, this is false, so we'll be again going to next iteration, we'll consider next I, and then I is oval, yes, and this becomes 3. And then we check whether C is oval here, and this is not, so will not be going inside this if condition, this second if condition. And here we are going again because 3 is greater than 2, so max count will become 3 and current count will become will have 3. So then afterwards this condition becomes true here, max count equal to K, because K is 3 here and max count is 3, will be just returning max count, will not be checking for other characters, because no use of checking for other characters because we have limit of taking the substring as 3, only 3. So and all the 3 characters in a substring are ovals, so that's enough for us, so we'll be just returning out. So I'll go through this example set 2 as well, you'll get an idea. So here more depth idea, like here we had characters together, but here we don't have that way. So initially this string is we all love you, so in this K is equal to 7 we got, and initially we consider using this for loop we iterate till 7, so LO till LO, and the number of ovals in this is O A E, so 3. And using here again we start from in next for loop we start from K, where we start from V, and we consider V is oval or not, no, uh, and W is so will be not doing anything, will not be adding going inside this if condition, and this condition also false because W is not oval. And then this becomes true, this becomes true or what, 1 2 3, so this will not become true, this will becomes false itself because 3 is not 3, we already have 3 and we got 3, so will not be going inside this if condition, this if condition because we have K7 and currently we got max count as 3. And then in next iteration we will be considering V and E, and we are leaving out E, so we have considered one oval and we left out one oval, so again max count is 3. And again we consider Y and we'll left out A, so now we'll have 2 ovals, and again we consider UO, we left out L, so we again get 3. and again we left out, we will leave 3L and we will consider U. So we will be having ovals, total ovals in from this in this substring of length k 7 k, which is 7. We have ovals for which is O, E, O, U. So here in this case this condition becomes true because current is 4 is greater than max count is 3. So yes, so max count becomes 4, and here these conditions also become true because sorry, this condition will not become true because max count we have 4, and we will be just returning the max count. So since iteration is completed, we will be just returning the max count, which is 4. So in this we are iterating through the string only once. Here we are iterating till k, till length of k, and here we are iterating length n minus k, where if you assume n is the length of the given string. So that is the reason only here we are iterating through only n times. So that is the reason time complexity is order of n, and space complexity is order of 1, because here we are just using only few extra spaces, like these are constant extra spaces. So the space complexity is also order of 1. And yeah, that's all for this video, and I'll share the link of the solution and the image in the description of this video. And thank you for watching.